Hi, and welcome back to this lesson on introducing model classes to our Spring Boot applications. This is part 2. And in this half of the lesson, we're going to look at how we can add a simple data field to our model classes to make sure that it's easy to tell them apart and easy to make them distinct, even if they have the same data field values, the same names or descriptions. And we'll also see how doing so will make some of the operations of our application a little bit easier. And then we're also going to look at extracting the data operations from our controller to get a clean, proper separation of concerns in the way that MVC is designed to be used. Okay. So actually, before we get started, I just noticed I have some unused imports here. Let me go ahead and clean that up. You can do this from the code, organized imports menu item, and that will clean up any that aren't being used. It's always a good idea to keep those clean. And let's see. Okay, so the issue we were looking at previously is that our application doesn't properly remove items from the list of cheeses. And before, this code is untouched from when we were using a hash map and when we were storing data as strings. And so, this worked when we were removing a cheese by name from a hash map. But now that we're storing cheeses in a list, in an array list, this isn't going to work. And in particular, one of the things we're going to want to be able to do is to determine which cheese to remove. And if two cheeses have the same name, it's going to be hard for us to tell them apart when we're looking at the data here. So what I'm going to look at is how we can easily set up an extra field to make sure that our objects are easily distinguishable. Okay, so here I am in the cheese model class. And what I want to do is I want to add a new field. So far we've only added fields that were sort of user-facing, that were visually or explicitly representing data for our class. This is going to be a field that's used in a much more internal way. So I'm going to make this an int, and I'm going to call it cheese ID. Okay, and this is going to be just an integer identifier, a unique number that will identify each class created from, or each object created from the cheese class as being different. And so, how can we use this field in a way that actually allows those to be unique? So to do that, I want to create a private static int, and I'm going to call this next ID and set it equal to 1. So static just means that, again, this field will belong to all instances of the class. It will be shared amongst all cheese objects. And so now I want to look at how I can actually use this next ID to initialize the cheese ID field so that it's unique for every single cheese object I create. So to do that, I'm going to make a new constructor, and it's not going to have any arguments. This is what's called the default constructor or a no-arg constructor. And within this constructor, I want to initialize my cheese ID field. And I'm going to initialize it to be equal to the value of the static next ID field. And then once I do that, I've already used that ID. So I want to make sure that when the next object is created, it gets a different ID. So let me increment the next ID field there, okay? So this will work if I create a new cheese object using the default constructor, okay? But this is behavior that I would want to happen regardless of which constructor I was using. So let me go ahead and come up to the other constructor I have, and in the very first line, use this syntax, this open parens, close parens. This syntax basically says call the default constructor for the given class. So I have to put this at the top of my other constructor, and this has to be the first line. And here, this will call this constructor down below and initialize the ID field. Okay, and then one more thing I want to do is to go ahead and create a getter and setter for my ID. Okay, and actually that did not put those where I wanted those to go. I like to group getters and setters together, so let me copy and paste those down below. Okay, there we go. Great. So now I have this cheese ID field, and this will be unique for every single instance of the cheese class, which is good. And we'll see how this works to our advantage when we want to delete cheeses. For our next step, let's look at how we can extract the data data management from the controller. So if we bounce back to the controller, at the top we see we have this static array list that's storing our cheese objects, and this violates the separation of concerns of the MVC pattern. So the controller should not be responsible for managing our model objects in any way at all. So we want to extract that functionality and put that into the model in a way that maintains the best practices and the proper separation of concerns that we should follow when using MVC. So to do that, let's go over to our models package, right click, and make a new Java class. I'm going to call this cheese data. Okay. And then the first thing I want to do within this class is just to cut this array list out of the controller and go put it in cheese data. Okay, so I want to preface this by saying that this technique we're using here of making a cheese data class that's going to handle the storage and access to our cheese objects, this is something that is more instructive than like practical. In the long term, once we learn to use databases and Spring Boot's database management machinery, we will not use classes like this. We will rely on some of the stuff that's built into Spring Boot and configuring and setting that up properly. However, that's a big topic in and of itself. It's pretty large, so we're going to approach that in a week or two. For right now, though, we still want to, kind of mimic that behavior. And so, this is going to be a good instructive way to approach this problem. It's also going to make the Spring Boot stuff have a lot more context and make a lot more sense when we do get to storing our objects in a database. You'll understand what's going on to a much higher degree because we've done things in the way we're doing them right now. Okay, so just a caveat there. So if we look at our cheese array list and the way it was being used in the cheese controller, that will help us determine what our methods in the cheese data class should be. So in particular, we can pretty much go to the places where we have errors now, having removed this array list. Here we're using the entire list of cheese objects. So I probably want a method that will get all of them for us. If I scroll down a little bit to the next error, I'm adding a cheese to the list, so I probably want a method that will add. If I scroll down even further, I'm removing cheeses from the list, so I probably want a remove method. And then finally, this one's not apparent, but we'll see why it's useful in a moment. We want a get by ID method. This will get a specific cheese based on its ID. Okay, so let's go ahead and start implementing these, and then we'll start using them in our cheese controller. Get all might be the simplest of them, so let's make it first. Public static. It's going to return an array list of cheeses. And we can just directly return this array list that we're storing internally. The add method, it's going to be a little bit more complicated, but not significantly so. This will be a public static void. It's not going to return anything, but it should take in a cheese to add to the list. And then we want to say cheeses.add new cheese. Okay. The remove method, it turns out, is going to use our get by ID. So let's go ahead and do the get by ID first. So let's say public static. This is going to return a cheese, right, based on its ID. And it takes in an integer. Okay. And for this, we want to look within our array list and find a cheese with that given integer ID. So let me again mention too that if you were going to build this in a more robust way, you would use a little bit of a different approach. And in particular, you would need to know about interfaces, which we'll be studying soon, and so forth. So this technique, some of the techniques and algorithms we're using here to solve this problem aren't necessarily the best in the sense of the broader Java landscape if we had all the tools of Java at our disposal. But again, I don't want to overwhelm you with new concepts, and I want to focus on the things that are really important. Right now, we're focusing on how we can properly extract our data from the controller. That's the most important thing, and kind of getting used to the patterns we can use to separate data from the controllers. And so delving into the world of interfaces and some other topics is a little bit outside of the scope of what we want to focus on. So again, just a caveat there, you will, after you learn about interfaces and how they relate to collections, you would see, and we'll talk about even, how you might come back to this code and do it a little bit differently and a little bit better. Okay, but for now, let's go ahead and look at how we can get a cheese by its ID. If I have this list and I have an ID, I can pretty much loop through the list and look for the cheese. So let me go ahead and say, let me declare a cheese local variable, and at the end I'm going to return it. Okay, and let's see, I want to say for cheese, candidate cheese in cheeses, if the IDs match up, I want to say that the cheese is equal to candidate cheese. All right, and this is a warning we're receiving that says that this local variable might not have been initialized, which is the case. If we don't find one with the given ID, indeed, it will not have been initialized. And so in this case, we need to figure out the best way to handle this. I'm going to say let's just initialize it to be null, and we'll be returning null if we don't find the cheese by with the given ID. Okay. So now this will return a cheese with a given ID. Let's go to our remove method and see how we can use that to remove a cheese. So let's go ahead and say this should be a public static void remove, and it's going to specify what should be removed by the ID. Okay, so this is going to be the most useful for us in the controller, where we'll most often have the idea of a cheese rather than the actual object itself. Okay, so I can say cheese to remove equals get by ID. So this is why we wrote get by ID first. We can look up the one that we want to remove using this method below, and then I can say cheeses.remove cheese. And it looks like I've just used the actual class name instead of the variable name. There we go. So that will remove the given object from the list. Okay, so we have 4 little utility methods we can use within this cheese data class. Let's go ahead and make use of those in the controller. All right, so up here, I'm returning the list of all the cheeses to the view on the index view. So let's say cheese data.getAll, and that will do that. Down here, we're adding a new object. So let's go here and say, let's say cheese data.add. Here, we're returning a list of all of them. So again, we'll say cheese data.getAll. And here we're removing a cheese. And so actually this is where we need to come back and fix our code. So let's go ahead and write this code the way we want it to work, and then we'll update our template to incorporate that information. Okay, so recall that before, when we were trying to remove a cheese, we would remove it by the name. Now we have these nice IDs at our disposal. So it would be great if I could, instead of receiving a list of strings, if I could receive an array of integers representing the IDs that I want to remove from my list. And then rather than looping over this, I can say for int cheese ID in cheese IDs. and I can say cheese data dot remove and use the ID. Okay, so that nicely uses this cheese data class. And notice that we've encapsulated all of the data operations around storing and accessing, removing, adding data into this cheese data class. Our cheese class itself doesn't need to know about how it's stored, and our controller doesn't need to know about how it's stored. It's only that information is totally encapsulated within the cheese data class. So one more change we need to make before we can test this code out is to go into the remove form and update it so that it now uses integer IDs rather than the strings. So let's go to our remove template. And here we've been using the name as the piece of data that represents the given object that should be deleted. And so we saw that we had conflicts when we had two different items with the same name. So let's go ahead and fix that. And instead of using the name, we will use the cheese ID. Okay. So now I can change the value of my checkbox to that, the ID here and the ID here. This text, this is going to be the display. I still want the user to see the actual name of the cheese, so I'm not going to change that one. I just want the more or less internal representation of the data that the user is selecting to be based on the ID. And then finally, I need to change the name of this. In the controller, I used cheese IDs as the name of the parameter that's coming in. And so let me go over here and change the name of my form element. These need to line up to match for that data to work well within the controller or to be matched up properly. So let's change it there. Okay, and I think that's good. We made a lot of changes, so definitely possible we made an error, but let's go ahead and test our code out and see how we did. Okay, the application is started up. Oops, let's go to, there we go. And to test this out, we'll need to add some items. Okay, so the add functionality worked. That actually hit the code in our cheesedata.add method, which is good. And we've also hit the cheesedata.getAll, which is used on this index view. So we know that those two at least seem to be working with that single test case. Okay, let's go ahead and add a third. All right, so now I have 3 items. So we've just exercised multiple methods within our cheese data class. We exercised the getAll method and the add. Let's go ahead and test out the remove method, and in particular the changes to our remove form. So here we have 3 things listed. Let me open up my browser tools and show you, even though changes aren't visible, this is the same way the form looked last time that we did indeed make changes here. See that now we have the value of each input checkbox is equal to the ID of that specific cheese. Okay, so previously that value was the name, and so these two cheeses have the same name, and it would have been ambiguous as to which one should be removed when we posted this form. Now, even though to the user, these still have the same name, the internal representation is based on an ID, and those IDs are unique. Okay, so that's actually a good thing. Let's go ahead and add, or delete rather, the first one. And we see that we did indeed remove the first cheddar cheese. Let's go ahead and try to delete more than one at a time. And there we go, that seemed to work. So the benefit of that is that we've just refactored our code into a way that separates the data management from the controller and also keeps that data management still independent of the model class itself. So that's a good pattern. It's a good way to do things. We'll actually use the same pattern in Spring Boot when we're using a database, even if we're not writing these cheese data classes ourselves or these classes like this. We'll still have things that play the same role. So it was very instructive for us to go through this exercise to see how this works. Then when we get to the place where we're storing data in a database, it'll be much more apparent what's going on. One final thing I want to show you in this lesson is about model binding. Okay, so let's go to I'm going to stop my server and go to my controller. And I'm going to use model binding in one specific way. Let's see, where do we want to go? Right here. process add cheese form. This is the method that is handling the request to add a new cheese to our list, okay? And it takes two items. It takes a cheese name and a cheese description, and then it creates a new cheese out of that and adds it to the list. So there's a nice technique called model binding, which will do a couple of things. One, it will reduce the amount of code we have to write when we're doing things like this, when we're handling form submission. And that becomes a much bigger deal when you're dealing with, say, creating an object that might have 10 different fields. Like think about creating, a user filling out a shopping cart information on Amazon, where you might have lots and lots of data fields, more than just two. And so this, you can imagine that, a method signature like this could balloon quite rapidly to deal with all of that data. So it'll help us with that, and it'll also help us with validation. And making sure that we're getting the right type of data to create our objects properly. And validation is the subject of a future lesson, but seeing how model binding works will set us up nicely for looking at validation within Spring Boot. So there's a nice technique I can use to have Spring Boot automatically create a cheese object for me when this method is called. So let's go ahead and delete these two input parameters. And I can say instead that I want my method to accept a cheese object called new cheese. And then instead of having to create it, I can just delete this line literally entirely. And for this to work, I need to do a couple of more things. One is I need to say that this is a model attribute. So I add that annotation that applies to this method parameter, model attribute. And then I also need the fields or the properties of this class to match up with the form fields. So if we look at our add form, I have a name field and a description field. I've currently, though, named these cheese name and cheese description, while if I look at my class, these are called just name and just description. So I need to update these to say that these are name and description. Okay, so what's going to happen when I start up my application now and try to create a new cheese is that when I'm in this form and I fill out these fields, the data will be submitted to the server in the same way it was previously, with a name and a description. When Spring Boot processes the request, when it's handling the unpacking of the request and the routing, it will see that it should go to this particular method, and it will see that this method expects a cheese object. And since I've given this the model attribute annotation, it will try to create that cheese object for me. And the way it will do that was that it will look at the cheese class and it will say, what are the fields or the public properties that have getters and setters that are part of this class? And in particular, there are these two right here, name and description, and it will try to match those up to the data that's in the post request that came from the form. And so any piece of data in the post request that matches up with a property of my class will then be injected into that class, will be inserted into the class. And then when our controller receives the cheese object, this will be a fully functioning created cheese object with the data from the request inserted into it. So let's just go ahead and run our application and see that it does indeed work. Okay, so let's refresh and let's go ahead and add a cheese. This is where that code's going to be called. And that indeed worked, right? So let's just go ahead and add another one. And to add this other one, well, let me go ahead and actually, I'm going to stop my server and start it in debug mode so that I can show you exactly what's happening here. This will kind of help bring the pieces together for you, hopefully a little bit. I'm going to set a breakpoint on line 39 right here, which is the one line in that method where I'm adding it to the list. Okay, here we go again. Okay, so I've stopped at this breakpoint, and let's inspect the objects that we have at play here. So right here in my variables pane, I see that I have new cheese, which is the input parameter to my method. Let's go ahead and expand that. And I see that it has a name property, and I see that it has a description property, and these correspond to the values that came in via the form. Okay, so Spring Boot has created this object for me, and then it populated these two fields via their public property getters, or their public property setters rather, for me. So what really happened here is that the constructor for the cheese class was called, and then Spring Boot then called the setters for those two values. Also notice that this cheese ID is set as well. So I have a cheese ID with cheese ID 1. So I just restarted my server. This is the first cheese I've created, so it's going to have the ID 1. So let me go ahead and let that play out. We'll see that if we go back over here, that was created correctly. And let me just show you a little bit more of what's going on. So in here, I'm just going to, within comments, show you the code that's being implicitly run for us by Spring Boot. So Spring Boot, when it's about to call this method for us, when it identifies that we want a model attribute of type cheese, what it will do is it will do the following. It will create a new object using the default constructor. Okay, so it's going to call the default constructor. That default constructor, recall, is what initializes our ID for us. So once we do that, we have an object that has an ID, but it doesn't have a name and description yet because those are not initialized inside the default constructor. Also notice that Spring Boot is going to call the default constructor. It doesn't necessarily know which other constructors we might have for our class. It can't predict what constructors you as the programmer are going to create for a given model class. So having a default constructor is going to be basically required for all of our model classes, because there are these situations where our objects will be created for us by the framework, and the only way that that can happen is if we provide a default constructor. Okay, so after it calls the constructor, it would then do something like this. It would say new cheese dot set name, and it would set that to be equal to something like this: request dot get parameter name. Okay, so this might not be the exact syntax. I'm a little fuzzy on what that exact would be, but this is more or less the spirit of what's going on. The framework will go to the request that's come in. It will look for a parameter that corresponds to the same name as the field we're trying to set, and it will call that setter. It will do the same thing for the description. Okay, and so this is why it's important for the names of the fields to match up with the form fields. This is the name of the data the data attribute that's coming across in the post request, and that needs to match up exactly to the name of the field in the class. If it doesn't, then Spring Boot won't be able to correctly initialize our objects for us. So this is all happening behind the scenes when you use this model attribute to bind your model class to the request handler. And so, in this case, we see that we got a couple of things for free. We see that we reduced our amount of code by 1 line. This code just kind of reads more nicely. It's a little bit cleaner. And I mentioned too that, were we to have a bunch of fields, maybe 10 or more different fields from the form, your method could get pretty hairy. This actually is going to help clean that up quite a bit. And again, we'll see the validation is going to be possible because of the way we set this up in a future lesson. So model binding, pretty useful, and we'll go ahead and use it a lot more in the future. Okay, so that concludes this lesson. You can go ahead and go forth and start creating model classes within your MVC applications, your Spring Boot MVC applications, and use them in the ways we've outlined. There's a lot to using model classes in a lot of different ways you can use them that are pretty powerful, and so we'll explore a few of those more in future lessons. Thanks for following along, and happy coding.